In this short series of videos, you will learn how to calculate the crack widths in reinforced concrete structures. The series of videos are all based on the book Structural Design from First Principles, Chapter 10, Control of Cracking in Reinforced Concrete. In this worked example, we're going to look at a slab that is cast first, followed by a wall that's cast on top of it. So you can see here, this is the slab, and then we've got a wall that's cast onto the slab. And the wall, when it is cast, is going to heat up slightly due to heat of hydration. It's going to heat up by 15 degrees Celsius. And then it's going to cool down and it's going to shrink. And the shrinkage is going to cause cracks to develop because the concrete that was cast first is going to push against the shrinkage, forming tensile strains, which will lead to this cracking. First of all, you need to calculate the minimum reinforcement requirement within this wall, and then to calculate the crack width due to this heat of hydration shrinkage, and then finally calculate the crack width 2 years after the slab has been cast. We're expecting that the wall is going to dry out within that time, and that's going to induce a further 180 microstrain of shrinkage. Now, it was discussed in one of the previous lectures that the guiding principle in this situation is to make sure that the tensile strength of the concrete at 3 days after casting is less than the tensile strength of the rebar. The tensile strength of concrete 3 days after casting is approximately equal to 1/20th of the 28-day compression strength. And using the formula that is derived in the previous lecture, we can say that the area of steel required is equal to the area of the concrete. We're going to consider just a 1 meter wide section of concrete wall, multiplied by the 3-day strength of the concrete divided by the yield strength of the steel. So we end up with 525 millimeters squared per meter, and we're going to provide this equally on both faces. So that would, if we use 6 millimeter diameter rebars at 100 millimeter centers, we'll end up with 566 millimeters squared per meter. Now we need to calculate the reinforcement ratio, which is the area of steel divided by the area of concrete. And then using the Eurocode 3 expression, we can calculate the crack spacing, which is 3.4 times the cover plus 0.34 times the rebar diameter divided by the reinforcement ratio. And now we can then work out what the free shrinkage strain would be, which would be the coefficient of thermal expansion multiplied by the change in temperature, which is 15 degrees Celsius. Now, the previous lecture explained how to calculate from first principles the restraint factor, and that is using this equation here. Now, it's fair to assume that the Young's modulus for the fresh concrete is less than that of the older slab concrete, and in this case we're going to say it's 70% of the Young's modulus for the slab concrete. So if we just input these data into here, that's the area of the slab, and that's the area of the wall. We can work out a restraint factor of 0.75. And then from the basic design expression, we can work out the restrained shrinkage strain, which comes out at 101 microstrain. Now we can calculate the crack width, which is simply that restrained shrinkage strain multiplied by the crack spacing. So we haven't got much in the way of cracking here. 0.07 millimeter thickness. So that's well within the acceptable limits. Now the 120 microstrain of shrinkage strain due to drying out will produce a final crack width, or a widening of the crack, of 120 minus the spacing of the crack, which is 716 mil, so we end up with 0.09 millimeters. So after 2 years we would expect the final crack width of 0.07 plus 0.09 gives you 0.16 millimeters, which once again is a reasonable crack width. I hope you enjoyed this short video on the control of cracking in reinforced concrete. There are 6 more videos on this topic available on YouTube and also in the book Structural Design from First Principles. I hope you enjoyed this, and do press like if you found it useful. Thank you.